So our next topic is model testing. Okay. So much time, money, and energy goes into the design, construction, and manufacturing of the hydraulic structures and machines. Okay. So there is involvement of a time, involvement of money, involvement of energy when you design or manufacture any hydraulic structure or a machine. So we have to minimize the chances of its failure. Okay. So to minimize the chances of failure, it is always desired that the test be performed on small size models of structures or machines. Okay. Instead of we place the actual machine for the practical use. So before its practical use, we have to manufacture its model and do some experiments on that model before its manufacturing. So depending upon the result obtained on the experiments, result obtained on the models from our experiments, we predict how that particular machine will perform its activities when we use in a actual situation. Okay, so an actual size structure or machine, okay, the actual size structure or a machine that we call as prototype. Okay, whereas its replica, okay, its replica we call it as the model. So the actual size machine is the prototype, okay, and the replica of the prototype we call as model. Okay, so on the basis of the results from the model, the performance of prototype can be predicted. On the basis of experiments we do on model, the performance of this prototype can be predicted. Now, this prediction is when this prediction is accurate. When you say this prediction is accurate, so for the prediction to be accurate, there should be a complete similarity. There should be a complete similarity between the prototype and the model. So far, the prediction to be accurate, there should be a complete similarity between prototype and its model. Now, this complete similarity we call as this term complete similarity we call as similitude. Okay. Now, we define the similitude as the complete similarity between the model and its prototype. Now, this complete similarity can be attained if the following types of similarities are established. Okay, so those are number one, the geometric similarity. The second one is kinematic similarity, and third one is dynamic similarity. Now, if we have established these three types of similarities between the model and the prototype, then we can say there is a complete similarity between the model and its prototype. So that is the similitude. Now, you see what is the meaning of geometric similarity? The geometric similarity means a model and its prototype are geometrically similar. Okay, the model and its prototype are geometrically similar. Now, what is the meaning of this term geometrically similar? Means the ratio of the corresponding length dimensions are equal. The ratios of corresponding length dimensions are equal. Okay, so then you can say there are few terms involved. One is the length scale ratio, that is LR. We can write as the length of the model divided by the length of the prototype. Okay, then there is area scale ratio, so that we can write as LM square divided by LP square, or that is equal to LR square. And there is a volume scale ratio, so that is VR, and we can write it as LM cube divided by LP cube, or that is LR cube. Now these scale ratios are to be established between the model and its prototype. Then you can say there is a geometric similarity between the model and its prototype. The next is kinematic similarity. Okay. Now kinematic similarity implies the similarity of motion. This is the similarity of motion. That means the ratios of velocity, acceleration, discharge, etc. are same in both the model and the prototype. Now these are same at homologous points. So you can say the velocity, acceleration, discharge, etc. are same at the homologous points. Okay. Now the homologous points are, these are the points of geometrically, or you can say these are the uh, geometrically corresponding points. Okay, or you can say these are the similar points. Okay. Now this also implies that the path of moving particle is same at the homologous points. Okay. So in kinematic similarities, we again have some scale ratios. So the first one is time scale ratio, that is TR, TM upon TP. We have velocity scale ratio, VR. Okay, we can write it as LM upon TM divided by LP upon TP. Okay, so I can write it as LM upon LP into TP upon TM, that is length scale ratio divided by time scale ratio. We have acceleration scale ratio, AR. We can write it as LM upon TM square, LM upon TP, sorry, LP upon TP square. Okay, so I write it as LR upon TR square. Then discharge scale ratio, that is QR, LM cube upon TM, LP cube upon TP. So that is LR cube upon TR. So these are some scale ratios that we have to establish in kinematic similarity. The third one is the dynamic similarity. Dynamic similarity means the similarity of forces. Okay, that means the ratio of all kinds of forces are same in model and the prototype at homologous points. So you can say the ratio of all kind of forces are same in the model and the prototype at homologous, correct spelling, at homologous points. Now say a fluid particle can be acted upon a force Fp. So we have six type of forces are there: the pressure force, the viscous force, gravity force, surface tension force, elastic force. Okay, so these five forces are acting on any fluid particle, and the result of these forces is the motion of the fluid particle. Means these five forces results into a inertia force. Okay, so we can write as Fi should be equal to Fp plus Fv plus Fg plus Fs plus Fe. That is equal to mass into acceleration. That is inertia force. Okay, so far dynamic similarity. Now the ratios of forces. So that means you can write Fi for model is equal to Fi for prototype should be equal to the sum of all these forces for model, sum of all these forces for prototype. Or you can also write it as mass into acceleration for model, mass into acceleration for prototype. Okay. So for complete similarity, the ratio of individual component of forces must also be equal to the ratio of the inertia force. If you see the individual components, you can see Fi for model divided by Fi for prototype. This is equal to Fp for model divided by Fp for prototype. Okay, equal to Fv for model, Fv for prototype, or Fs for model, Fs for prototype. That means for complete similarity, the ratios of the individual component forces must also be equal to the ratio of the inertia force of the model and the prototype. Okay. Now further with these equations, you can also write the ratio Fi upon Fp for model should be equal to Fi upon Fp for prototype. Or you can write as Fi upon Fv for model is equal to Fi upon Fv for prototype. So you can write such equations also for dynamic similarity. Okay. Now you can note down one important point here, that it is also to be noted that dynamic similarity is possible only if there are geometric and kinematic similarities between the model and the prototype. Okay. So you can say dynamic similarity will only be there if there is geometric similarity plus kinematic similarity will be there. Okay. Now this is because without the geometric similarity, the ratios of velocities, acceleration, etc., at homologous points are not be seen. Okay. If there is no geometric similarity, if there is no geometric similarity, then there is no kinematic similarity. So for dynamic similarity, these two similarities must be there. Okay. Or you can say for kinematic similarity, the geometric similarity must be there. Okay. So if there is dynamic similarity, so that means there is already kinematic and geometric similarity are there. So dynamic similarity means there is a complete similarity between the model and the prototype. So that is in similitude. Model and its prototype are in similitude. Okay. So now depending upon this, we have now some similitude laws. For complete similarity, we have different similitude laws. So those laws are comes from the dimensionless numbers. Okay. So the importance of each dimensionless number is now the associate with the force by which it is related to the inertia force. For a particular phenomena, you can say one force is predominant. So according to that force, you have the dimensionless number. According to that dimensionless number, you can use that law that becomes a dimensionless model law to establish a similitude between the model and its prototype for that particular physical phenomena. Okay, so that we see. Next, what are the similitude laws we have to establish a complete similarity? Okay, now thank you.